Hi! Today we're going to learn about parametric differentiation. Let's say we have to solve for dy dx of y is equal to 5d cubed plus 3d and x is equal to e to the 5d squared powered plus 7d squared. So how do we do this? As we can see, we have to find dy dx, and we're given two functions. One is what y is equal to, and one is what x is equal to, and they're both in terms of d. So what do we do? Well, let's just sidestep from this problem for a second. So let's say that we took the derivative of the numerator. So we know the derivative of the numerator would equal y prime, or dy dx, dy dt. So the numerator would be dy dt, because this is in terms of d. The function is in terms of d. Now, let's say we took the derivative of the second function. So this would be x prime, or dx dt. So this would be dx dt because it is the derivative of the function x in terms with respect to d. So what happens when we divide the derivative of the numerator by the derivative of the denominator? So the derivative of the numerator is dy dt, and the derivative of the denominator is dx dt. So this becomes dy dt times dd over x. Because we remember we have to multiply the numerator by the reciprocal of the denominator for dividing fractions. So when we do these, the two dd's cancel out, and you're left with dy dx. So that's how we would solve for the derivative of parametric functions. So let's do that here. So dy dx would be equal to, the derivative of the numerator is 5d cubed plus 3d. The derivative would be 15d squared plus 3 over the denominator has a derivative of e to the 5d squared power times 10d plus 14d. So dy dx is equal to 15d squared plus 3 over e to the 5d squared times 10d plus 14d, or e to the 5d squared power times 10d plus 14d. Today we learned about parametric differentiation. Thank you for watching this video.